Hi guys, hope you had a good Easter. Hi guys, hope you had a good Easter. We're going to have a look at a few bits and pieces today for the stats chapter, Hi guys, hope you had a good Easter and you were safe. Hi guys, hope you had a really good Easter and looked after yourself and had lots and lots of chocolate and watched loads of films. If like you, hi guys, hope you had a good Easter, ate loads of chocolate and looked after yourself. I made the mistake of buying Frozen 2 and have now seen it approximately 10 times in 2 days. It is wonderful. Anyway, we were having a little look at some statistics before Easter and we did some linear coding. We did a little bit of data cleaning, standard deviation. I think you looked at the large data set as well and maybe did a little bit of manipulation with a spreadsheet. We will look into the large data set in more detail because it's a very confusing spreadsheet and I want to make sure I go through that with you in person. But today I'm going to recap a little bit of box plots and cumulative frequency curves from GCSE, but also do something new called linear interpolation. So the first thing we're going to do is just look at a box plot and just have a quick recap of what all the points are. So we've got the median here, also called Q2. I'm going to mark on each of the box plots for girls and for boys where the median is. So median is here for the girls and the boys is that one there. It's a line that goes through the box. It's not always in the centre, it's somewhere in the box. The upper quartile, also called Q3, is the end of the box. So that is Q3, there and there. Okay. The lower quartile, Q1, is here and here. Just give me a moment. I'm just going to pause the video whilst I kick the cat out because you can probably hear him making odd noises in the background. Okay, I'm back. So, as I was saying, the lower quartile Q1 is the start of the box. That's where a quarter of your data is. The highest and the lowest value, are your whiskers. So these bits here are called whiskers. This is a box, this is a whisker. So the highest value is the end of the whisker, here and here. And the lowest value is the start of the whisker. So then you can tell a lot about the data. So the girls have got a higher median, so this could suggest that the girls did better in this test. I'm not quite sure what it is. Let's imagine it's a maths test. You could argue that the girls did better because they had a higher median. You could also argue maybe the boys did better because the boys got the highest mark overall. However, that could just be one boy. We don't know. And it was one of the boys who also got the lowest mark. If we talk about consistency, that's how big the box is. And this box is smaller than this box. That would suggest that the girls were more consistent. So the girls' data was more consistent than the boys, but you could argue that the boys got the highest mark, the girls got the highest median. It's a difficult call. Let's have a look at something that you might not have done back at GCSE. So the range, I'm sure you do know how to work out, is just the highest. Not quite sure why I'm writing in yellow, but let's go with it. The highest minus the lowest. So the highest value, take away the lowest. The mid-range is something that you probably haven't calculated before. And the mid-range is the highest value plus the lowest value, all divided by 2. Something else I should have written down before and I forgot is the interquartile range, IQR, and that is the upper quartile minus the lower quartile, and that is basically the difference between the start and the end of the box. And if you've got Q3 here and Q1 there and you're subtracting it, then that tells us that there's 50% of the data in that box. 3/4 take away a quarter. So that's how we talk about consistency with the interquartile range. So 50% of the girls got values between 15 and 25, 50% of the boys a lot more spread out, so the girls were more consistent. Now if you want to work out an outlier, outliers are slightly different in box plots when we talk about quartiles as it is to using standard deviation. So there's 2 different ways of working out outliers based on what data you're using. So Q1 minus 1.5 lots of the interquartile range and Q3 plus 1.5 lots, I'm really struggling to put a dot in there, lots of the interquartile range. So you take the interquartile range, times it by 1.5, you then take it away from the lower bound, you add it onto the upper bound, and any values less than this or bigger than this are classed as your outliers. And if you do have any, what you would do is you'd use a cross actually to mark them on your box plots. So they would be any outliers there, indicated by a cross. So Q3, take away Q1, times it by 1.5, take it away from your Q1, add it onto your Q3, and you get 2 new numbers. Any of your individual values bigger than that or less than that are outliers. You obviously couldn't do it from the box plot, you'd have to have the individual data to do that. So that's box plots. Nothing hugely difficult there, just things to remember really. I'm not going to go over plotting a cumulative frequency curve in detail because again it's not even GCSE, it's kind of key stage 3 stuff. But a quick recap for when you do a cumulative frequency curve is you have to work out the cumulative frequency first. So if you're not quite sure what that is, remember it's like a running total. So your 12 you get just from here, 29 is 12 plus 17, 39 is 12 plus 17 plus 10, so it's a running total. If you add all of those together you get 70, which is the final value there. Now to plot a cumulative frequency curve, you plot the upper bound against the cumulative frequency. So for the first one here, the upper bound is 2 and the cumulative frequency is 12. Upper bound here is 4, cumulative frequency 29. 6 against 39. 8 against 53, 10 against 63, 12 against 70. And then you get a nice kind of elongated S shape. And the curve always starts at the lowest possible value. Not always 0. So here it's 0 because that's the lowest value in the table. It won't always be 0. And if you're looking at, for example, house prices which start at maybe £100,000, then it would be very wrong to start the curve at 0. So that's a quick recap on how to plot it. Now, linear interpolation, not something you will have heard of before, although we have used this word. we've talked about interpolating and extrapolating. Extrapolating is when you look at data outside the range. So we were looking at scatter graphs and we were trying to figure out what would happen outside the range of the data. That's called extrapolation, and you can't assume to know what's going to happen to the model outside the range of the data. Interpolation is looking at within the data, and this allows us to more accurately work out the median. So if we were doing this back at GCSE, for example, and I asked you to work out the median, you would figure out where halfway is. So the median here, total of 70 values. I want halfway. I'm looking for the 35th item, 35th person. Well, there's 12 people in here. There's 29 in the first two groups, so the 35th person is going to be in there. And back at GCSE, you will have just written down that as your answer. But actually, we can be a bit more accurate now. And the idea is we're going to be looking within this group, and we're going to try and calculate roughly how far into that group the 35th value is. And we end up with a slightly unusual formula, very big formula. It's all words, and you're not given it in the exam, so it's something to remember. So it's lower bound of the class plus, so I start off with the 4, which is a lower bound, plus I want to look at how far into the class I am as a fraction of how many people are in that class, and that's going to be times by the class width. So if I look at mine in particular, I'm after the 35th item, which I've said is in that group. The lower bound of that class is 4. And just to point out here, be really careful. There's a lovely overlap here, so it's not difficult. This one ends at 4, that one starts at 4. Or anything remotely close to 4. So 3.99999 recurring would be in there, so we call it 4. I've seen questions where they leave a gap, so this might be 3.5 and that might be 4. Be really careful when there's a gap and think about what your bounds might be. Okay? So if there isn't this overlap, just have a real think about what your upper and lower bounds are. So my lower bound is 4. Position in class. Well, if we look here, this class ends at 29. That means the 35th item is going to be 6 into that class. So this one starts at 29. The 35th item is 6 on from 29. Class frequency is 10. And the class width, 6 take away 4. So the class width is 2. So I'm going to do 6 divided by 10, times it by 2, plus 4. And you end up with 5.2 as the median. So it's a lot more accurate than just saying it's in that group. Okay? I'll do another one similar-ish, same data, but instead of just finding halfway, the 50th percentile, we're going to look at finding the 45th percentile instead. Okay, so we're going to look for the 45th percentile. You can find any percentile you want. So I want to know which item is the 45th percent. Well, there's 70 data values. 45% of 70 is 31.5, so I'm looking for the 32nd item, or the 32nd person. 12 people in there, 29 in there. So again, the 32nd person is going to be in that same group as before. So, lower bound is going to be the same, 4. I am after the 32nd person, and this group starts at 29. So the 32nd person is 3 into that group. There's still 10 in there, and the class width is still 2. So this time I'm looking at the person who's 3 into that group. 3 divided by 10 times by 2 plus 4 gives you a 45th percentile of £4.60. So you can do it for any of them. So this is your lower bound. Use your cumulative frequency to figure out how far into the group you are. These are your class frequencies, and the class width is how big your group is. What I'd like you to do from there, please, try the questions on your chapter checklist from exercise 12.3a, page 323. Any concern, drop me an email, drop me a message on Show My Homework, whatever, it's absolutely fine, and I'll get back to you. And once you've had a go at that, we'll move on to looking at histograms. I think from there we've got some scatter diagrams, bit of regression lines, and then that's that chapter done. Then we move on to Venn diagrams, things like that. Okay, keep safe, best of luck. Let me know if you have any questions about that work. Bye for now.